This is question 8 of the CAPS DBE November 2022 paper 1. So the graph of f dash of x is this graph here is drawn. The graph passes through points P and Q is given, and R. Those are all given. Determine the values of M, N, and K. So our f dash of x. The first thing to notice, this is not the original graph. This is the first derivative. Mx plus n plus k. So it wants the unknowns in the quadratic function in this parabola here. But first thing we can use is the x-intercept form. So x-intercept form would be x minus our first x of our x-intercept with the unknown a value. And then don't forget the a value, x minus our, so this is the general form using the x-intercept form of a quadratic function. So we have, the reason I chose this form to solve for the unknowns is because we have both the x-intercepts, we have P and Q. And we also have a third point on the graph, R. So you need 3 points in order to use this. As you need both your x-intercepts and you need a third point to solve for A. Now let's put in everything we have. So if we sub in our unknown R, it's going to be 0 and 1. So 1 goes where the y goes. Oh, that's a 0. And our x's are zeros. But our two x-intercept x's are minus a third. So minus a third is plus a third. And the other x-intercept is 1. So minus 1. So we end up with, those are all the pieces of information we had from the given information, and we just need to solve for A. So 1 equals a third minus 1. So it would be minus a third A equals 1. Also just divide by minus a third on both sides. And this tip in times is 1 times minus 3. 1 times minus 3 is just minus 3. So we have our A value that we're not quite done. We wanted M, N, and K. So we have our A values. We can sub it into the x-intercept form over here. So our f dash of x, we have our A value, but we still have x plus a third and x minus 1. And just need to, the final step is just times this all out and to have it in standard form. So minus 3 x squared plus 1 over 3x minus 1x minus a third times these two can, a third minus a whole is minus 2/3. So if you want to do this intermediate step, so minus 2/3 of x, if adding like terms. And then we just times in the negative 3. Negative 3 times x squared is negative 3x squared. Negative times negative plus 2 over 3, top times top, bottom times bottom, it's 3 times 2. So this will be just, the 3's can actually cancel out there. That would be even better. So this would be 2x. Oh, now we can, that 3 hasn't been cancelled out for the last one, but we can do it again. So the 3's cancel out and it's just 1 and 1. And you'd have 1. This is from the previous thing. Okay, so that's the final part of the question is just to actually answer it. So what is M, N, and K? So they're in order, M, N, K. So our M is minus 3, our N is 2, and our K is 1. That completes the first section of question 8.1. Number 8.2. They give you the original curve. So they give you f of x. is this. So our f of x is equal to minus x3 plus x squared plus x plus 2. 8.2.1, determine the coordinates of the turning points of f. So usually you would take f dash of x equal to 0 and you'd be able to get your x's and you could sub it back into your original formula to get the corresponding y's. But in this case, we already have f dash of x over there. So we can just let our f dash of x equal to 0 in order to find the x's of the two turning points. And then we take those x values, we sub it back into f in order to find the corresponding y's in the original curve. So the first thing I do here would just be to divide through by -1. It just makes it easier. You can also put this straight into your quadratic formula if you want to. Open up two brackets, we have a trinomial. It's going to be 3x and x and 1 and 1. We need to times together to make -1, and we need to plus together to make -2. So it's going to be -3 plus 1. Because this one's negative, there's two different signs, and the sign of the bigger one, when you times it together, will take the same sign as the middle term of the trinomial. Right, so we have two situations. There are two brackets equal to 0. That means one of those brackets has to be 0, because anything times by 0 equals to 0. So we know that 3x plus 1 equals to 0, or x minus 1 equals to 0. We take the 1 over the equal sign, it's -1, divide by 3. So x is equal to -1/3, or take the 1 over the equal sign on this side, and we have x equal to 1. So those are our two x's. We need to sub them back into our f of x in order to find our corresponding y's. Let's just grab that. Yeah. Okay. So f of, whoopsie, f of -1/3 is just simply wherever you see an x, you put -1/3. And when you're putting this in your calculator, just best to just leave it there so that you can work out the next one. So you put this all into your calculator straight away, and the corresponding y is 49/27. So will be the y for our first x that we got, our first turning point, and the other turning point would be f of 1. So if this was still in your calculator, you can just delete the bit with the -1/3 in, and -1, put the 1 in instead, x. So it becomes similar to something like this. So our f of 1 ends up being 3. We're not quite done. It's the question asked for the coordinates of the turning points. So we want the actual coordinates of the turning points. And we can write those as, first it's -1/3 and 49/27. And the other turning point was 1, 3. So 1, 3. Those are our turning points. (8.2.2), it wants you to sketch the graph of f, indicate the coordinates of the turning points, which we've already done, and the intercepts with the axes. So we just need to do the intercepts with the axes. For intercepts with the axes, for the x-intercept, you let y equal to 0, and for y-intercept, you let x equal to 0. So we can just quickly get that done. So letting y equal to 0 will give us our, is the harder one. So let's do the x equal to 0 first. It would be f of 0 is -0/3 plus 0 squared plus 0 plus 2. So obviously you could do this by inspection, but just to show the working behind it, it's just going to be 2. So our y-intercept therefore will be 0, 2. We have our y-intercept done. X-intercept, the working that I like to use, it's a little bit harder. So we're letting our f of x equal to 0, got minus x cubed, x squared. So for the first factor, you use the calculator. So on your calculator, you press mode, number 3. So press mode. And it might not be 3. I think it's either 3 or 7, depending on which calculator you're using. But it basically, it's either 3 or the number 7, but we're looking for tables. And this is going to give us f of x equals 2. And here you've got to type your function in. You type in minus x3. So you press alpha, and then you see a red X above the bracket on my calculator. It might, but this is red, the alpha is red, in order to get your X's. And quickly get your function in. Oopsie, this is an X. Just check that. Yeah, it's just an X. So plus X plus 2. You press equals, it says start on the calculator. So you want to start at -9, I usually do. And then it asks you end question mark. I like to end at number 9. Then it says step. And I say step 1, that's fine. Press equals. And you'll get a column like this with x and fx. So x is just the x values that exist for this function. And your fx, what you're looking for, your fx is your y values, and what you're looking for is where y is 0. You want to know what x value makes your y 0. So if you just scroll, press the down button, I get at x equals to 2. At x equals to 2, I get my y value as 0. So we want f of x as 0. So we're saying we're looking for an x-intercept. So our y is 0. There's 0 on the y here. So if that's x, in this case, it's on the side. X is 2. So that's how you can get it. To be fair, you can get all of your, sometimes you get lucky, you can get all of your x's in this using the tables method, but I use it just to get the first one. So the first one we have, so if x is equal to 2, what that's saying is that your x is equal to 2. And essentially we could take that 2 over x minus 2 is equal to 0. So our first factor is x minus 2. Our first factor is x minus 2. So let's take a look at this, the method to find the other 2 factors. F of x is equal to minus x3, x2 plus 2. Okay. So here we have our first factor. And what we're trying to do is factorize this cubic function. There's a section in the math called polynomials in South African textbooks, but we're trying to factorize this cubic function. So for the first term, you ask yourself, what times x will make our cubic term? So x times negative x squared will make the cubic term. So for the first term, it's easy. For the third term in the trinomial, you ask yourself about the constant term. So we want to make the constant term. So we have -2, and we want to make +2. So we have to times -2 by -1 will make +2, equal +2. So the hard part is this middle one. So the way we get the middle one is we times these two together. And -2 times the negative x squared is 2x squared. And we ask ourselves, what do we need to plus or minus to this 2x squared to get the x squared term in the, so we want to know what do we need to plus or minus to this in order to get the x squared term, and our x squared term is plus x squared. It's just a 1x squared. So we have to minus we have to minus x squared in order to get that, in order to get our x squared term. So 2x squared minus x squared gives you x squared. But now when we put it here, just remember we only having it, this is a trinomial, so it's just an x over there, x to the power of 1. Okay, so that's the method to get the second bracket. I'll look at this, and it doesn't look pretty to me, so immediately I'll just take a look at my factor here, and this A, B, C, I'll just put into my quadratic formula. So for the quadratic formula, it's x is equal to minus b plus minus square root of b squared minus 4ac. And looking at this, we're going to get 1 minus 4. I'll just check on this because it's going to be 4 times -1 times another -1, which is going to be negative. So we have a situation where underneath the square root is going to be a negative number, which is imaginary. It doesn't exist. We can't do it. So I think for this one, we can safely see that there's only one real answer. Oh, that eraser is basically useless. Okay. So this is, you can do the full thing. I could see it from there. The -1, -1, we have a negative answer under the square root sign. That means it's not real. So this is invalid. So for this question, x equal to 2 is our only real x-intercept. So then our x-intercept will be coordinates of 2, 0. So now we've got everything we need to sketch the graph. So we're ready to sketch our graph with all the information we need. Just to note for the turning point here, the 49/27, if you press 49/27 on your calculator and press equals, and then you hit the SD button, just to switch it around into decimal. So this is in decimal form, otherwise it's hard to tell where it's going to fall on your graph. So I just put that in decimal form in order to actually graph it. I'm going to give myself a axes here. Nice and neat. This is, you don't have to, so it asks for turning points and intercepts with the axes. It's not drawn to scale. So we just do more or less our turning points go 1, 3. So not drawn to scale. So 1, 3 is one of them. And our other is minus a third. So just an incy little bit, and then 1.81. So a little bit up. Just put it there. Minus a third, 1.81. Okay, those are turning points. Then this was 1, so I'm just not giving myself an awful lot of room here. Our x-intercept was 2, 0. And our y-intercept is between these two. It's at number 1.81 is almost 2, so it's kind of right over there. It's a 0, 2. Now we need to know it's a, let's see, it was a negative cubic graph, so it looks like this. Negative shape goes down up instead of up down. If you want to remember that that's the negative shape, but we need to make that shape. So what I do is I start at the x-intercept because I know it can't turn back up here. So there's no more points on this side. So it has to keep going forever. And then it must turn at the turning point through the y, and it needs to turn at that turning point again. Gonna go. Okay. This obviously more or less the shape that you're looking for. And just check that you got everything they need. Coordinates of the turning points and intercepts with the axes, and you're done. Number 8.3. Point E and W are two variable points on F dash. So here's our F dash. And they're on the same horizontal plane. Okay. H is a tangent to our F dash graph at E, and G is a tangent at W. They intersect each other, H and G, the two tangents, at D, which is a point AB. It wants to know the value of A. So this is our F dash graph. And we have H as a tangent on, you can imagine, on one side. These are on the same horizontal plane. So then this would touch the F dash at E. That's just a visualization. And then we have another one. It has to be on the same horizontal plane. So they're going to be the same distance away. That's sort of, those are straight lines, believe it or not. And they meet at D, A and B. Well, this is what I kind of visualized in my head. The same horizontal plane. And so that means the tangents have to meet in order to at D, A and B. And this was, this was H was for E and G for W. Okay, that's line, there's two tangents. My question says, what is the value? Write down the value of A. Well, in order for this to be true, our E and W points would have to meet, our A is going to be directly in the middle of E and W. Our A is directly in the middle of E and W. And if we look at that point, it's going to be on our axis of symmetry here. No, it's going to be directly in the middle of P and Q. It's the same point, because this is our turning point here. And you can see it's the same X, different Y. They're the same X. It's just directly above the line on, it's directly above the turning point X. So we're going to end up with the same X that is halfway between P and Q. Even if our E and W are sort of over here, we can still do it. So we can just add together the X's of P and Q and divide it by 2, halfway between them. So -3 + 1 divided by 2 will give you your A, and A is equal to 1/3. Right, 8.3.2. Determine the values of B, H, of B for which H and G will no longer be tangents. Will no longer be tangents. Well, let's take a look at the properties of a tangent quickly. So a tangent is a line that touches the curve once. A tangent can only touch the curve once. So there's two cases where this won't be a tangent anymore. There's one is if it goes up, and it's not a tangent because it's not touching the curve at all. And another one is if the line is brought down, shifted down. So the gradient stays the same, but the line is shifted down. And then it starts to touch the curve more than once. And it's not a tangent anymore at that point. So we want what value of B. So this is B, that's where the two cross each other, where the two tangents cross each other. Let's take a look. So currently, if we kind of want to know, whoopsie, we want to know what value of B makes both the tangents sort of, this should be drawn to scale, makes both the, oh, I can't, let me make that better. So we want a value of B that makes the tangents not tangents anymore. So they cross each other. Okay, so for this to be true, just remember that these lines can shift. So if we keep bringing our B down, then our tangent lines will just keep shifting and staying as tangents. And by a tangent, I mean they only touch once. So we brought our B down here in this case, and it hasn't, the tangents are still tangents, right up until it touches that turning point, right up until it touches that turning point. It's then these lines cannot anymore be tangents because let's see if another way of explaining this. So let's take a look at what is our B right now. We can do that by subbing in the A value, our A value of 1/3. I think that actually those visualizations are trying to think of how I can explain this, sort of how I'm seeing it. So if we take f dash of 1/3, we get -3 1/3 squared plus 2 1/3 plus 1. And this gives us 4/3. So we know that B is 4/3 currently. B is 4/3 currently. As soon as we go lower than that position where those tangents are meeting, those lines are going to cross the curve twice. This is by nature, the tangents are already only touching once. As soon as we lower these lines, they're going to start touching twice. They're going to start touching twice. So we could say that if B is less than 4/3. I just want to think that other thought process through all the way, just for the sake of it. What would happen if we brought B down and we kept tangents sort of touching higher up? Interesting. I wonder that. So this, why can't this be true? Because the gradients have changed here. Let's take a look at this on Desmos. Okay, so I've brought up the Desmos. I'll have to check this a little bit later again. Desmos.com is the graphing calculator that I use. So now notice when I put in this point D, just grab the annotation here. This is point D, and this is our f dash of x. So our point D here is 1/3, 4/3. A fascinating thing. So what I wasn't seeing, I can see it now, is that as soon as you bring it below this point, so say we put D over here, our 2 points, it's gonna do something like this. Maybe that, or if we had, they're both on the same horizontal plane, we could even have this situation with our 2 points in 2 lines, still in the same horizontal plane. What about if we had they pass through a point over here, still in the same horizontal plane? So it's every single time I'm doing it, they're touching twice. They're not tangents for sure. What happens if we bring D up a bit? If we bring D up a bit, then it stays tangents. We can still work with that. Oopsie, 10, that's touching. So if we bring D up, if we bring the Y value of D, the 4/3, if we go up from 4/3, then it's still, so it's only really when we bring it below that they're no longer tangents. They touch this curve. They're going to touch this curve more. H and G are going to touch this curve more than once. Interesting. So the quicker way to do this question would have been to recognize that this is in fact, the turning point of f dash of x straight away. We should have recognized that. Right. I think that might be the end of 8.3.